Welcome back everybody to linuxacademy.com. My name is Terry. Today's course, we continue our preparation for the Linux Foundation Certified System Administrator exam. In this video, what we're going to be talking about is file permissions. Now, file permissions, again, if you are unfamiliar with the concept, Linux treats everything, whether it is a device, a file, or a directory, as if it were a file. So when we talk about file permissions, we're talking about permissions that are not unique to directories or files or block devices or physical devices that are referenced in our system, but they apply equally across all of them. So let's take a look at permissions on our system. So let's do an ls-al, which will give us all of the directories and files in our home directory, and it'll tell us the file permissions, the file and directory owner, as well as the group owners. And you'll see that on the left-hand side, there is a listing of R, W, and X, and an indication at the top, on the top left, whether it's a directory, as well as some dashes that indicate permissions that might be missing, and the file system file owner and directory owner for each individual entry in this directory. So permissions are done in groups, and there's 3 primary groups, and each one, if you look at the first letter here in this sequence, this will indicate whether it's a directory or not. So the first letter has nothing to do with permissions. It tells you the type of file that we're referring to. Thereafter, you'll see that there are groups of 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And these groups individually indicate in order the attributes for the user, for the group, and for everyone. So that means that, for example, this bash rc file, the owner, which is the root user who we're logged in, has read and write permissions, no execute permission. The group, which happens to be root, has read, no write, no execute, and everyone has read, no write, and execute. Now, from a file perspective, those are fine permissions if you don't happen to be the owner of the directory or the file system that it's on. From a directory perspective, if you don't have execute permissions, you won't be able to go into the directory and even view it. So in this case, the owner has read, write, execute of the directory. The group and everyone else has read and execute, meaning we can switch to the directory, we can look at what's in the directory, but we can't make any changes. So again, it's owner, group, and all users, and each file or directory has read, write, and execute permissions. And we could look at it just the way we did, ls-al. So when we want to modify permissions, we can use the command called chmod or change mod. It's modifying permissions for a file and assigning permissions explicitly, either by using a text-based reference or a binary reference, and we'll show you what we mean by that. So the permission groups used in shortcut are U for owner, G for group, and U for owner or U for user, and O or A for all users, and the permission types as they're listed here are R for read, W for write, X for execute. So for example, if I want to change the permissions for the data without test tar.gz file, then what I can do is I can say all users get read, write, and execute. How would I do that? I would do a chmod, the user type, in this case A. I'm adding read, write, and execute permission for all users for the data backup gzip file. So data underscore backup underscore gzip. Now when I look at that particular file, you'll see that I have given all permissions right here. And you'll notice that despite the fact that this file did not have read, write, execute here or here, those groups also have those, because when I specified all, that includes all members of any group, and that includes all users on the system. So because I use the most generic definition of permissions, it backfills the permissions for everyone else that applies. What does that mean? So if we take a look at, and we'll do it at a group level this time, we'll say that data without test.tar.gz should have read, write, execute permissions. So we're going to do a chmod g plus rwx data without test.tar.gz. Now when we look at that, you're going to see data without test.tar.gz has read, write, execute permissions. Now it didn't flow up to the group, did not flow up to read, write, execute for the user, because the user may not be a member of the group, and it doesn't make a differentiation based on the fact that the group and the username are exactly the same. The only way that I can apply permissions using a single command for all groups and users for a particular file is to use the all or the a. Now I can go back and fix that by rerunning the command that we just ran, and instead of putting in the G, I can say now I'm adding for the user read, write, execute permissions, and now I should have read, write, execute for my particular user. So I can manage that way, and we've already looked at how to manage groups, and we can do a change group or a change user if we wanted to manage the user ownership of that. And we'll talk about users and group ownership later, but what we're talking about is permissions for files. So owners and groups have permissions associated with them, and we can do them either as text-based, or we can use them as binary. In binary, what we can do is we can change multiple groups at the same time. So if we want to assign a read permission, a write permission, or an execute permission, we have different numbers that are associated with them. So read is the number 4, W for write is the number 2, and execute is the number 1, and they can be added together. What do we mean by that? Well, let's take a look at one of our files. We have the data backup gzip tar gz. So let's assume that we want to give read, write, execute permissions to the owner, and we only want read and execute permissions for the groups and all users on the system. Or we don't want all users on the system to have any access to it. So what can we do? We do chmod, and in this case we don't have to indicate whether we're doing a user, group, or all users on the system. We assign numbers for each one of those. In order, we assign 3 numbers. The first one being 7. Why is it 7? Because for read, write, execute, we have the number 4 plus the number 2 plus the number 1 equals 7. Now for read and execute, R being 4, execute being 1, we have the number 5. And since we want no permissions for everybody else, if they're not a member of the group and they're not the owner of the file, we want them to have no access to the file whatsoever, then we do 750 permissions to data backup gzip tar.gz. And when we look at that file now, we'll see that we have read, write, execute, which is represented by the number 7. We have read and execute, 4 plus 1 is 5, and 0, which indicates the permissions for everyone else on the system. Now, I find it easier to run the binary notation for the users on the system unless I'm just making a change for one particular user. So if I'm just making a change for myself, for example, so if I want to make sure that my .vm info I have read, write, execute on, then I might just do a change mod for user, and then all I'm saying is I want read, write, execute permission on .vim info. And then now I have it. Whereas that way I don't have to remember that the user group and all other users on the system get 0 permissions. I could have done the same thing by doing a chmod 700 on .vim info, because you'll see that won't actually change anything. the original permissions of .viminfo look like read write. So read write would be what? Read is 4, write is 2, and then everyone else had nothing. So I have 600. So in this case, to restore my vim info, all I want to do is go back to 600. Or I could have done change mod user plus read write on .vim info. And it would have done the same thing. So I get exactly the same thing regardless of how I run the permissions, whether I do it by binary or whether I do it by user group or all users and adding or subtracting particular permissions. I grew up with the older binary notation. It works universally across all systems regardless of their age, whereas some very early Unix systems don't support the ASCII-based notation for changing permissions. So I tend to just remember that R equals 4, W equals 2, X equals 1, and then I can change all three at the same time exactly to what I want. So that's all there is for managing file permissions. You can do it for files, directories, all the way through character devices on your system. Just be careful about what you change permissions to, particularly on special devices that are, again, represented as files in Linux. That's all there is to it. My name is Terry for Linux Academy.